My name is Marcelo Santos, and I'm a professor of geodesy at the University of New Brunswick, Canada. See some of my qualifications at the end of this video. This is a series of 5 videos in which I overview 5 climate-related news published in February this year, in such a way to highlight their importance. In this video, we will talk about Arctic sea ice has reached a 10-year high. Early in February, a bullet appeared in the U.S. National Snow and Ice Data Center website saying, Northern Hemisphere-wide sea ice coverage since 1st January 2006. It did not get much attention. The Weather Channel might have been the only news channel to mention that. The fact is that it has been really cold up there in the Arctic due to a growth in the polar vortex. The image shows the ice extent as per February 2020, and its borders are very close to the mean borders of the period from 1981 to 2010. The sea ice extent has decreased since its last peak in 1979. Plots, such as the one we can see now, are usually shown to people to support that. The plot shows sea ice area using data from the NSIDC, both monthly and the 13-month average. The red line represents average from 1979 until 2019. 1979 is considered the onset of sea ice satellite monitoring, even though satellite data goes back earlier than that. Area covered by sea ice is defined as having at least 15% sea ice cover. But Arctic sea ice has been monitored in many different ways much earlier than that, with observations of more local and regional character, showing large variations and a very small negative trend. This figure shows the time series of the August sea ice extent anomalies in units of 1,000 kilometers square in the Arctic Ocean along the coast of Russia, Siberia, and Alaska, the Kara Sea, the Laptev Sea, the East Siberian Sea, and Chukchi Sea, as compiled in a paper by Polyakov and others, published in the Journal of Climate in 2003. The authors analyzed Russian historical records of Arctic sea ice extent and thickness going back to the beginning of the 20th century. They used records collected by Russian hydrographic surveys and commercial ship observations of summer ice edge by the Soviet Polar Aircraft Fleet created in 1929 and by systematic aircraft and ship observations from the Kara Sea to the Chukchi Sea since 1932. There was a gap during the time of the Second World War. Aircraft ice edge observations continued until being replaced by satellite-based observations. Polyakov and others concluded their study stating that long-term trends are small and generally statistically insignificant, while trends for shorter records cannot represent long-term tendencies. They also stated dynamical forcing, wind or surface currents, is at least of the same order of importance as thermodynamical forcing. That is something we can understand if we consider that most of the Arctic has no sunshine for half the year and that it is basically a shelf floating on water. Variations of sea ice are of interest, partly due to the high albedo of sea ice, which reflects much of the incoming solar shortwave radiation during the summer. In a simple analysis, if not reflected, this radiation might warm the ocean water, starting a positive feedback leading to more warming. But this simple analysis ignores the increased ocean evaporation when the total sea ice cover are reduced in size. Increased evaporation would result in an increased cloud cover, leading to an increased reflectance of incoming solar radiation, which would help to balance the process. Finally, the decrease or increase of sea ice has no effect on the global sea level. Just a compliment. Irresponsible politicians have predicted over and over again that there would be no Arctic sea ice cover now. Well, we're far away from those catastrophic predictions. Alarmists just reuse them, pushing the date of the Armageddon to the future. Definition of alarmist: a person who tends to raise alarms, especially without sufficient reason, as by exaggerating dangers or prophesying calamities. It is funny to see that Arctic sea ice refuses to melt as ordered. Developing renewable energy is something good, but we don't need to kill ourselves during the process. And we need to stop pollution, for the simple reason that this is the air we breathe, the water we drink, and the soil on which we grow our food. We cannot poison them.